Hello, Mr. Green here, and I'm just going to take you through first off the first lesson for Year 11 Key Stage 4 Physics. This is the unit concerning forces, and our first lesson will be to understand how to calculate resultant forces. I'm going to do a brief recap on what forces are and how forces affect things. I'm going to look at some calculations, and you're going to try some at the end. So to start off, let's have a look at what we're going to do by the end of this video. So by the end of this video, we should be able to state units and some different types of force that will affect different objects in different ways. From that, we should be able to calculate the resultant forces of an object. I'll show you some examples first off on how to do that, and then there'll be a section at the end where you can pause the video, try it yourself, and I'll take you through the answers. First up, though, we need to look at some key terms that we will be using as part of this lesson, and we'll be using these throughout the forces topic. So first up, force. A force is said to be a push or a pull which acts upon an object as a result of its interaction with another object. So objects apply forces upon each other. If we're talking about forces, we normally give it a monetary value, so it'd be 12, 15, 16 or so. But to understand that it is a force and so other people know, we need to give it a unit. So a Newton would be the unit of force. That's got the symbol capital N, and it goes at the end of every answer that we give concerning forces. And finally, the phrase resultant force. The resultant force is when more than one force acts upon an object, the combined effect can be represented by a single force arrow which shows the resultant force. So if we have an object and two forces are acting on it, the resultant force would be the overall force that's taking place on that. We're going to look at how to calculate the resultant force when different things are occurring and when different values are applied. So first up, what is a force? Bit of Key Stage 3 revision here. If we talked about a force and I asked you to not just name a force, tell me what a force is, in Key Stage 3 we normally state it is a push or a pull or a twist. So a force can exert a push on an object, it can exert a pull on an object, or it can force the object to twist and change its shape maybe. Now when we get to Key Stage 4, we need to be a little more sophisticated when we're discussing forces and stating what they are. So we state that a force is something that can change the motion of an object. A force may change the speed of an object. It may cause it to speed up, it may cause it to slow down. This is where the term resultant force becomes important. If there is a resultant force on an object, then its speed will change. We're going to see how we calculate resultant forces in a second. As well as changing the speed, a force can also affect the direction of an object. So a force is something that can change the motion of an object overall. It may change its speed, it may change its direction. So how do we represent forces when we're looking at an object? Well, we've got a car here that's driving along the road. We'd say simply, at the moment there are four forces at least acting on that car. There are four forces at least that are acting on any moving object. Now to represent these, we use force arrows to do them. Now the first and probably most obvious force that's taking place on that car is the force that's pulling it down. Represent that with an arrow pointing straight down, and we'd refer to that as the weight of the car. So the weight of the car is pulling down. It's a force that's caused by the gravitational attraction of the Earth to the car and of the car to the Earth. It pulls it down, it means that it's going to stay on the surface of the Earth. Now our problem here is, if we do have just weight acting on an object, then the overall force or the resultant force would be acting down. That means that car would be acting down, that car would be moving down. Now we know the car, as it's on the road there, is staying level on the road. So if there is a force pulling it down, there must be an opposite force pushing it up. And that force we call the reaction force. In the example we've got here, the reaction force and the weight are exactly the same as each other, meaning the car neither moves up or down. We'd say those forces are balanced. Again, we'll look at this further on in the next few lessons when we look at Newton's laws of motion. Now this car is moving forward, so we know there are at least two other forces acting upon that car. For a car to move forward, there must be a force pushing it in the forward direction. We refer to this force as the thrust force. The thrust is provided by the engine. It's a combination, or it's a transformation of energy in the fuel into kinetic energy to push the car forward. Now, If you've ever been in a car and you've wound the window down and maybe stuck your hand out from it, or you've been in a convertible car, you know that the wind pushes directly back at you. There are air particles as you're moving forward that are opposing the motion of the car. Any force that opposes motion, as far as contact is concerned, is referred to as friction, and in this case we could call it air resistance. But any force that opposes motion is known as friction. Now, we have our car there, we have the objects, we have the four forces acting on there, but if you're asked to represent forces, you don't have to draw a picture of a car or a person or a ball or whatever object it is where the force is acting on it. We can simply do this. This is referred to as a free body diagram. We have the object where the forces are acting on in the centre of it, and the forces emanate from the centre of that. And from this, we can use this diagram to help us now calculate our resultant forces. So that free body diagram represents the car we've seen on our previous slide. Don't have to draw it in there, just have to make sure that the forces are emanating from there, the arrows are coming from the centre of that. So, resolving forces. Here's where we look at our resultant force first off. Our first example is an object where there is one force acting upon it. That force is 5 newtons. So what would our resultant force on that be? What is the overall force? Well, if there's no other forces acting upon there, the resultant force would be 5 newtons. But that's not the end of that story. There's 5 newtons of force acting upon that, but it's acting to the right. Forces are vector quantities, and a vector quantity means it has a size and a direction. So when we're giving answers stating what the resultant force on an object is, we need to give the size of that force in newtons, and we also need to give a direction. At the moment, I've chosen to state it's to the right or to the left, but there are other ways of representing this, and as we progress through lessons, you'll see these other ways of representing the direction. So what if there's more than one force acting upon an object? In the case above, we've got one object, one force of 5 newtons, and one force of 7 newtons. In order to get the resultant force, what we need to calculate is the single force that would have the same effect on the object that the force is being applied to. So instead of 2 forces of 5 newtons and 7 newtons acting on that, what one force would have exactly the same effect? We can see the forces are acting in the same direction, so the rule in this case is when forces are acting in the same direction, the resultant force is calculated by adding these forces together. Makes it quite a simple equation. In this case, it would be 5 plus 7, so our overall force would be 12. Giving that answer in an exam though, you get the mark wrong. You need to include your units, and because it's a force, you also need to indicate your direction. So the resultant force would be 12 newtons to the right. What about in opposite directions then? In this case, we've got an object where we have a force of 7 newtons acting to the left and 5 newtons acting to the right. When the forces are acting in opposite directions, we change what we do. The resultant force is calculated by subtracting the forces from each other. The larger force is acting to the left, so the resultant force will eventually act to the left. In this case, we would have 7 newtons take away 5, leaving us 2. And again, when you're writing your answer, you need to include the 2 newtons, include your unit, and the direction, 2 newtons to the left. Okay, I'm going to leave you now. If you pause the lesson at this point, there are 5 questions here which you can calculate the resultant force of. When you think you've calculated them, if you unpause it, and we'll go through the answers. Okay, let's go through the answers. So for number 1, we've got an object with a force of 4 newtons and 6 newtons, both acting to the right. They're both acting in the same direction, so that would be 4 plus 6, giving us 12 newtons to the right. Question 2, similar one. We've got 0.5 newtons acting to the right, 6.2 to the left, exactly the same way, 6.7 newtons to the right. Question 3, 400 newtons and 800 newtons, both acting to the right, so our resultant force is going to be to the right. Because they're acting in the same direction, we add them together, 400 plus 800 gives us 1200 newtons to the right. Question 4, if we look at the top of the question, it tells us to calculate the resultant force in newtons. Now our original values are given us here in kilonewtons, so we need to convert our figure to newtons. There are 1,000 grams in a kilogram, so there are 1,000 newtons in a kilonewton. So to change that into newtons, we simply multiply that by 1,000. So in this case, it would be 8.7 times 1,000 gives us 8,700, and 12.4 times 1,000, 12,400. We add those together, we get 21,100 newtons to the right. Could also be said to be 21.1 kilonewtons. However, our question has asked us to give the answer in newtons. The bottom, we have a very similar scenario. 4 kilonewtons to the right is 600 to the right. We only need to convert our first one. It's 4 kilonewtons, so 4 times 1,000 would give us 4,000 newtons. Add that to the 600 because it's acting in the same direction, and our answer is 4,600 newtons to the right. Okay, second set of questions now. Again, 5 questions. If you can calculate what the resultant force is on there. So if you're going to attempt that, if you could pause the video now and restart it once you've attempted. Okay, let's go through these. We've got 4 newtons and 10 newtons. 4 newton acting to the left, 10 newtons to the right. So we've got the occasion where they're acting in opposite directions. The rule is, if they're acting in opposite directions, we subtract them from each other. The direction in which the bigger force is acting is the direction in which the resultant force would act. So in this case, 10 newtons take away 4 newtons gives us a resultant force of 6 newtons to the right. Same scenario underneath it. 15 newtons to the left, 12 newtons to the right. They're acting in opposite directions, so we subtract them, but the larger force is acting to the left in this case, so our resultant force would be to the left. Gives us overall 6 newtons to the left, 15 take away 12. Question number 3. 100 newtons acting to the left and 65 newtons acting to the right. Again, the bigger force is acting to the left, so our resultant force will be acting to the left, and it's simply 100 to take away 65, which gives us 35 newtons to the left. Question 4. 17.6 newtons to the left, 12.7 to the right, acting in opposite directions, so we need to subtract 17.6, take away 12.7, gives us 4.9 newtons. The larger force is acting to the left, so it would go to the left. And our bottom one, 300 millinewtons and 1,200 millinewtons. Now again, like kilonewtons, we need to convert this because we want our answer in newtons. In order to convert from milli to normal, we divide by 1,000. So our first one would be 0.3 newtons, our second one would be 1.2 newtons. We do 1.2, take away 0.3, which gives us 0.9 newtons to the right. The larger force is acting to the right, and so that's where our resultant force would act. Please feel free to review this video again. I hope it's been helpful in helping you to calculate resultant forces, and there will be further videos helping us to make other force calculations and talking about Newton's laws. Thanks very much for listening. See you soon.